anti-entropic. We'll see soon what it means. But I want to start with this sentence written by Carl Jung, one of the psychoanalysts and psychologists most important in the 20th century, that it says that our intellect has created a new world that dominates nature and populates it with monstrous machines. He is reflecting about the industrial period. He says, despite our proud domination of nature, we remain its victims, for we have not even learned to dominate our own nature. Slowly, and it seems inevitable, we are approaching disaster. Well, it's a very pessimistic, catastrophic thought, but we are experienced that everything is changing and we must put ourselves into action. Architecture in all its scales, all from the small to the very large, from buildings to urban scale, is one of the human actions that consumes the most resources. So there are many reports where you can appreciate how architecture consumes resources, consumes energy, and pollutes the environment. So what I want to say with this for the young people is that we have an ethic compromise with the society that we cannot forget. These following slides are in Spanish, but I am going to speak in English, of course, and I think you can understand easily. We are talking about transumo or transume in English. It's a kind of new word, a new word that invented a North American economist called Daly, talking that about not only about consumption, but something bigger than consumption, because you have to take into consideration the input and the output, the input of resources and the output of waste, the whole cycle of what we do in architecture. You need to take a note about the materials and how the materials are produced from nature, metals from mines or earth, soil from the soil or whatever, no? The transformation and fabrication, the consumption, and finally the waste. So the whole cycle is what we call transumo in Spanish, transume in English, but this, as I tell you, a new word. Because we are working land or the earth is alive because the energy we receive from the sun. And because we started in disorder, but we now are in a more or less equilibrated entropia. So it's less strong than used to be long time ago. And that's why in the earth there is order. Everything is under order. Okay, but now we are consuming more energy that we receive from sun. And there is an imbalance of this situation, and we're provoking disorder and energy, not good energy, that is disordering in a kind of non-structured organization. So we have to be aware of this, and as well about what we usually talk about sustainable development. Sustainable development was thought at the end of the 20th century to cover the necessities of the world, what we call the third world, people that are in process of developing through the sustainable development with the help of the developed countries. But what has happened is just this. It's an appropriation of the concept by the first world countries. For what? For an unlimited development, provoking what? An increasing of the consumption, permanent increasing of the consumption. So we have perverted in some way this concept. So because the unlimited development, this kind of development without control and sustainability are just in some way the opposite. So not possible. We could say the sustainable development is unsustainable, but we are talking continuously about sustainable development. We must be aware even about our words. What can we do? Well, our goal must be the maximum possible, the greatest possible development. That's it. There is a limit. Cannot be unlimited anymore. So we must be aware of all these issues. I have been working on that and have written different publications, among them this book that was released in 2018, so I mean 3.5, 4 years ago, where we can take a notice about how architecture, how art faces the concepts of every time, no? Every period of the human being gives a different response. So if we look at the ancient periods, I mean Greek and Roman period, we understand that they were really extraordinary good artists, mainly in sculpture. But for example, you can see here this painting that they were unable to express the space in between the objects or the figures. You can see here with these three ladies, I don't know the name in English, las tres gracias, we used to say, is a mythological theme that painters have used along the history. But you see these figures, the bottom part, the position of the three is completely, it's a mistake. But it was not a mistake. That time they didn't know what we later as human beings learn. For example, the modern perspective. Sorry, something is going here. In the Renaissance period, you can see we formulated the contemporary perspective. This is not only an issue of drawing, it's an issue of how to think. With the modern perspective, we started with the rationalism that dominates our way of thinking. Okay, we were able to generate a concept of a space through mathematics, through a perfect geometry that permits to position every object in the space. Okay, so architecture moved and art moved to another position. And moving forward, when the scientists decided to work, or were interested in working with movement, they work with the conics, curves, parabol, hyperboloid, and so on. And art as well was affected and you can see how architecture changes to more dynamic forms with more curves as well. And if we follow our path, we found how finally the rationalistic way of thinking defined by philosophers like Descartes or Leibniz, they decided to organize the space, as you can see here, as we understand, with three parameters and three axes, okay? And this is our basis even for the GPS, and so all the technology we have now. And of course, architecture was changing more towards a cubic response, because we were used to represent architecture through three projections, the faces of a cube. And this kind of idealization of the space is what we use daily in our daily life. So the response of the architecture is all these architecture like boxes. But nowadays, the situation has changed. The theory of the relativity by Einstein at the beginning of the 20th century, and all what has happened along the 20th century has moved us to another kind of concept of our space, a concept of our goals, and architecture is moving as well. You can see this kind of folded architecture, folded forms or shapes. In this slide, you can see, for example, on the left, kind of more rationalistic representation, in this case contemporary, but feeling this kind of very static, solid, classical solid is architecture by Mario Botta, the architect Mario Botta. And the following two in the middle are done by the architect Peter Eisenman, North American, who was involved in the architecture as a process, not as a fixed form, but a form in generation, in process, generating this kind of movement of a systematic movement in process. And finally, this kind of forms without forms on the right by Greg Lynn, another North American architect, who deals with forms or shapes that could be in many different appearances, but all of them the same. So I'm finally nowadays trying to imitate nature. We are trying to follow the architecture not only in process, but in process due to, or in progress, due to different parameters. We introduce the parameters, we choose a primary shape or form, and according to this, the form is self-generated. We don't generate fixed forms, but we generate forms that are making itself as nature does. We are not a form, we are a law. I mean, human being, for example, we have many shapes along our life. We are a code, and this is what we are working now, no? This kind of topological structures or shapes, or this kind of world of datascapes, or trying to introduce parameters in the situation. So for you to understand how we have moved, I bring here these two domes. Okay, on the left is a dome very well defined, we could say. Okay, and on the right you can see a dome is more or less a bit strange, a bit diffuse, but you can appreciate both are really similar. But the two of them correspond to completely different periods. On the left, the dome is the typical dome by Buckminster Fuller, this architect, North American architect in the 60s. This period, the second half, but in the middle of the second half of the 20th century, that used to do this kind of geodesic domes like this. As you can see, this is the mechanical process, industrial process, new materials done in the industry, all of them come from a prototype, are reproduced by the machine and are assembled. Now we are going to see a very contemporary and experimental dome, okay? So it's a dome done by Neri Oxman at MIT. Very, as you see, very surprising because it's done by living organisms, by worms, silkworms. So we are trying to focus our attention to another part. This belongs to the past industrial area. Is the Pompidou Center, and on the right, you can see a design, contemporary design as well by Neri Oxman, but it's not a shape. It's not only a shape, it's a code. I mean, on the left is the past, the industry as we used to know, and this is the industry as we are learning now. You can see how these shapes are not just design of a one hand, but are designs of a law or a code. This is a genetic process with genes, and how the forms is self-organizing. So it's completely different, a new situation. We can produce in a different way, and we can think in a different way. We could say, are we facing a paradigm shift? Probably yes. We are just in the border of the mechanicist era to the biotechnology era and digital era. So joining everything. So we can think that the situation is changing. I have been working on how to learn from nature along the years, and finally many of the researchers and the projects done were released in this book in 2019, and as you can see, we write in the cover of the book. The issue is this: could the study of bone structures in animals and the structural behavior of plants lead us to conclusions that improve the efficiency of architectural and civil engineering systems? This is the question. Huh? Can we learn? Well, we did it through biology and getting inspiration from natural forms to produce innovative techniques that inspire architecture in a different way. For what? For being more sustainable, more ecological, of course. But you young people that are there, first you have to change your mind, okay? To start this new way of thinking, you have to clean before your mind. And that's why I have this picture here to ask you, what do you think is this? The blue doesn't matter very much, only the white square. Probably many of you are thinking, okay, it's nothing, or it's a white sheet, or it's a light, or nothing else. But in fact, this is something. It's a cow eating grass in a meadow. You say, okay, this is probably, you are saying, okay, this is a joke. What is the grass? My answer is the cow ate the grass. And then what is the cow? Well, the cow left because there was no grass anymore. So it's a completely different way of thinking. Okay, are you ready? Then we repeat, okay, again. Now the yellow part doesn't matter, only the white one. Probably many of you are thinking, okay, this is not only a white sheet, but probably is many cows eating a lot of grass. No. But this is another completely different thing. This is a real one. This is a real one, was this, a knife without a blade that has lost his handle. So, and this is an impossible object, but by the sculptor Henry Karelman. Henry Karelman was very well known at the end of the 20th century, because this kind of very, I don't know how to say, surrealistic object. This is one of his collection. So this is real. If you change your mind, you can see many things in this white light, okay? The same than looking at this image that I like very much to introduce in my lectures. Many of you probably know, but when I ask what is this, it's a natural phone, of course, but it's not so easy to discover that is the tip of the leg of a fly increased 200 times, okay? It's a new look at nature. If I see the scale, this scale, and I appreciate this shape, I understand why a fly is able to stand up in a ceiling, and I cannot, but she can, or it can. Okay, the fly can, but I cannot. And that's why the relationship between weight and structure, in this case, microstructure. So we have been researching, for example, in cactus, how cactus that is a plant that grows in a very dry climate needs to preserve humidity at maximum. And this kind is a container of water, in fact, a cactus. And the structure is very interesting because all this folded skin that a cactus has permits enlarge the volume or decrease the volume, and as well because the folded it has, some faces are facing the sun and others faces are in shadow. And because of the difference of temperature between the ones that are with sun and the other ones in shadow, the air moves, is balancing temperature and produces a microventilation. So many strategies to to survive in this kind of hard climates. We have been analyzing natural structures. For example, here you have a standard concrete column, standard construction. But what if we check a natural structure, for example, human bones, a leg in this case? The bones are not with the same section continuously. The sections varies depending on the point of the necessities, because the efforts, okay? And what is very interesting is that according to different investigations done by others, that the comprehensive strength of a bone is greater than the reinforced concrete. Amazing. And even is the tensile strength is similar to the one of the cast iron, but weights a third. That is very important. Natural structures save energy, saving material. We study as well laminar structures like the how's the name? The water lily leaf, okay? And this is a structure that was studied even in the 19th century by John Paxton. You can see here the picture of John Paxton with his young daughter put in a water lily leaf, okay? Because this very light and thin structure is able to weight to support a big weight, and was the inspiration for the Crystal Palace. This the face on the top is really flat, but if you see the bottom of the leaf, you can appreciate this wonderful structure of veins, and the veins are void. They are not massive. They have air inside. It's a way to make the structure lighter, and it's a way to increase the buoyancy that the water lily needs to live. We were studying how this geometry performs, why these veins divided into several parts, or when they decide to divide. And there are many reasons, okay, important structural reasons. And even according to standard programs, digital programs to calculate structures for structural calculation, we decided to calculate a slab considering the geometry, simulating the geometry of the cactus, simulating radial and concentrical organization of the structure, or simulating a grid that is very simple for a human being to produce. But you can see that the geometry that best performs is the one that imitates the natural organization. So we have to move even in this field. And as well, we can get inspiration. This is a project we did many years ago, get inspiration, how the water lily leaf captures air to heat itself and so on, and working on folded structures. And an exercise we did in the workshops about folding structures. You can see how a sheet, a piece of paper is able to support only because the geometry, because it's folded, okay? Is able to resist many times his weight, many times, as you can see. And we research about how structures in nature use air. Natural structures are not massive, are really using void, using the air. Here is another question I can do to the young people attending the lecture. This is an eagle, okay? And I can ask you how big is an eagle? It's quite similar to a human being, not that much. It's shorter, around 1 meter tall, but almost 2 meters wide with the wings open, okay? So, but consider it's not that far in size from a human being, and a human being, the weight used to be, usually is around 80 kilograms, 70 kilograms, 60 to 100 kilograms. We can try to guess how much an eagle weighs. What's the weight? Well, you can see that an eagle, even up to 2 meters wide, where the weight is only 4 or up to 8 kilograms. Well, it's wonderful because it's built with holes that the engineer Larry Collet said many years in the 20th century. Things that have no weight but have strength. That is the birds in general. All of them is a permanent process of pneumatic structures to be more less massive with our lighter structures. The same if we take a look of a microstructure of butterfly wing, or microstructure of leaves on the left, and on the right, the cell of the cellulosa cell. That is the cellulose is the main material for wood. You can see a tree with this kind of torsion in his fibers, and even the cell of the cellulose cell moves with this disposition of fibers into helicoidal way to absorb torque efforts. Okay, you can see as well how lignin, the main material of wood, has a compressive strength even superior the concrete, the strength of the concrete. It's wonderful how natural materials are able, and getting inspiration of all those natural forms that we look with completely different eyes, as I told you before. So you can produce designs. Those are designs that done by our students in different workshops, okay? In this case, exploring torsion with a module, okay? And getting inspiration as well from trees and how they organize the veins. The veins has a micro composition, okay? This is the structure of a vein, okay? These are kind of puffy structure, okay? We replicated with straw, this kind of straw we used to drink sodas, no? And trying to guess the capacity of resistance capacity. You can see other tests in different workshops. Even a TV produced a documentary about this, and we put a stone and we put the straws. And finally, when the big car is kind of a small trunk went over both, the stone was broken, and the straws, a light structure, resisted the situation. Let me just show a bit. The stone was broken, and the other was only deformated, okay? So I'm getting inspiration from this kind of straws. Well, you can design, this is a free imagination, you can decide what you want, but we are not the only ones that are working on that. You can see projects by others exploring how replicate nature to be more efficient. Of course, the master was Prioto. And getting inspiration from the cocoon of the silkworm. We designed this bridge in China, and this another building that gets inspiration not only from the cactus, but as well from the spider web. That is a project for China as well, from Chengdu city. Combining this with exercises done in the workshops about Bionic or designing inspired by nature. Okay, as you can see here, how if you put sand in a table and make holes, beach sand, and you make holes, suddenly this wonderful geometry happens. The same than in the eyes of insects or the skin of snakes. Nature, because of physics only, it's not design, it's the superficial tension, they generate these wonderful geometries, okay? And we can use this in the design. In the workshops, you are not doing something about modules, I think. I believe, I think that your professor told me. And that's why I bring you this kind of exercises with simple elements that can generate hyper surfaces, even self-supporting surfaces, generating different approaches to the design or even to the architecture. Very simple elements. And even this in a first workshop we did in Sarmisegetusa long time ago. You can see these beautiful designs done with this kind of plastic forks that you can buy some coins, okay? And this is a wonderful design because the module permits, because the repetition organize wonderful structures, or even this dynamic structure with single sticks and pins, clothes pins, and you can organize this kind of ideas, no? Fine. And nowadays we move a big a step forward because the digital fabrication, we can organize a closer design to nature, producing easily this kind of shapes and forms as well. Well, because the inspiration on all these elements in nature, our research, we designed along the years all these kind of buildings you can see here, that for us is like this kind of panoramic of different flowers. All of them belong to the same code, but they organize in different shapes, coherent different shapes. And here you can see a kind of ideal city with all our buildings in the last 2 decades, more or less. Okay, some of them done, built, I mean, others just a project that in place in different places and countries, from Spain to China, India, or whatever. Okay, and but to finish, well, still there is some minutes. To finish this lecture, I will focus on 2 projects that we are just working now. We are involved in the process just now. One is very experimental, that is this one, how to try to implement another renewable energy in buildings. In this case, using alive organisms, living organisms in construction. In this case, microalgae, moving from the photobioreactor, from the industrial production to transform them in facades, or as you can see in urban landscape? Well, microalgae provide biomass. You can generate biogas and electricity, and they provide value-added products as well for food or for pharmacy or whatever. But they reduce as well. They absorb CO2. That is the great difference with other renewable energies, and they save energy and can clean and purify water. So this is why they are really promising for future. So we are trying to use surfaces of the city. So a new task for our facades or for our architectural envelopes in order to have a bio-sustainable city. The idea is to use roofs and facades to grow microalgae there, and then to crop this microalgae and produce different final products. This is a short video. Getting water from rain or from the network, using CO2 from the city for growing algae, so it's cleaning. Then with the centrifugate, the biomass, reuse partially or generate, for example, watering for plants and for agriculture, or biodigester to produce biogas, and as well electricity, as you can see. Okay, this is a scheme of the metabolic system, a whole cycle. Okay, here in this other video you can appreciate this kind of whole cycle. So collecting water from dark or gray water and from rain. Then we need some concentrate of microalgae, CO2 from the atmosphere, sunlight, and that's it. With that we can grow algae, and then we can return this biomass for different purposes, as I have mentioned before. So it's a way to produce energy in the city. So thinking the city as a factory of energy. This is design done by others, okay, but it's very nice. You can see how to implement this kind of industrial elements in the new aesthetic of architecture, or other samples of bioreactors integrated in the architecture done by us, that you can see here, or even this one, okay, combining even vegetation, why not? This kind of designs, there are many of them. We are now testing, trying to produce these trees, artificial trees, like a kind of urban scenario, and this is a real project right now, in this moment. Of course, we have produced a lot of research and scientific literature about how this kind of photobioreactor performs, the transmittance, how we can improve the energy efficiency. And even we did last year a research with combining our university with MIT, how to capture CO2, considering a facade or certain size like this one, and considering how we can collect water, the different species of microalgae, and so on. We calculated that we can save a large amount of CO2, so we can clean CO2 in the place that is produced, I mean in the core of the city, no? In the heart of the city. We were working some years ago in this project that finally didn't work. Is a fountain, a prototype bio-fountain in the urban roundabout. Okay, this kind of designs, I'm not sure, well, it's not the video here, doesn't matter very much. And you can produce beautiful designs, moving water slowly with microalgae inside. The designs could be, well, it depends on your imagination, of course, but as well, we calculate the biofixation of CO2, of the capture of CO2 for a clean environment, and others design. Okay, and now we are working on this. Okay, this is a real one because we got the interest of a city hall in the Great Madrid metropolitan area, and they are putting the money, and they want this. So these are the realistic prototypes that now are under fabrication, the first prototype, to organize this kind of landscapes. Okay, or that in the future, who knows, could be something larger, like this, used for different purposes. And another project we are working just now on is more standard, we could say, project. And I want to explain what we understand about building green. Okay, it's a structure that exists in the University of Alcalá, in the new area, hangars for aircrafts. Okay, you can see the structure. This structure was built at the beginning of the 20th century. It's supposed that is in the origin of the flights in Spain, so has a kind of heritage. It's very important for aviation, so for aircraft history. Okay, and even the structure is quite interesting. So you can see some photos of when it was built in the middle of nowhere, very close to Madrid, and now this area belongs to the University of Alcalá. And you can see that the structure has a really a shape really very attractive. The rhythm of this structure, concrete structure for aircrafts, is very attractive. So it's something that the university needs to preserve, but they don't know what to do. Finally, they decided, because it's placed in the area of the botanic garden, to make a garden, a botanic garden inside how you say, a greenhouse, no? A greenhouse. And they decided to appoint me to organize this. The structure has two ends at both extremes, two structures without value, but the piece in the center really is really amazing. And the location is this one. All that what you see here belongs to the university. It's the campus that is placed outside Alcalá city. We have several campus inside Alcalá city belongs to this historical one, and is UNESCO heritage. And this is the new one in a territory very dry, because it's the landscape typical there. And here in the middle, you can see the structure, the hangars placed. Well, the first issues we wanted to, because all this plot is really not nice and divides the campus, the buildings in the lower part, and in the upper part, even the train station that is in the lower part. We decided to use this structure as a connector between areas. I mean, it's not only the building, but the building integrated in the urban and integrating the urban. Okay, that's why we decided to work on the urban aspects to understand what we were going to do, connecting through the already existing paths and with another paths that we provoke. Okay, trying to connect the main points of the campus and trying to give some kind of interest to the percourse or to the path. And this decided to divide even the organization of the building. Okay, and this is finally the building how we are working now, but we organize it in three three parts. As you can see here, each of them focus on different landscapes of Spain and belonging to the different climates we have. We have the Atlantic and cold climates, we have the Mediterranean and continental climates, and we have the subtropical in the Canary Island that is placed in the middle of Africa. You know, it's archipelago, but in Africa. Okay, we have different climates, and we organize in this way the greenhouse. And you can see here how we organize the ubication of plants, percourse, a corridor in the following level, and some boxes in the upper level, and in the two extremes, any buildings, like an envelope of the former structures. This is the idea. So, but the goal was not to be really very respectful with the 16 structure, because it's an heritage. It's not historical, I mean, no Baroque nor Renaissance period, but it's contemporary heritage, we could say. So the idea is to respect us at maximum and to work with very light elements, okay, elements that don't disturb at all what it's important. You can see here some aspects, and in the upper level we can introduce some kind of boxes or bubbles, light bubbles that can be used as meeting rooms or work rooms, okay, here, but very light structures. Of course, we took into consideration all climatic aspects of winds, sun, and this determined the position, the angles, and whatever of the structures we were using. And we analyzed different systems of how to implement heating and refrigeration systems. And even working with other professors at the university, we decided a completely innovative system in such a way that we took advantage of the warm in summer to heat water that we keep crop in a tank in the soil, and in winter, using this warm, we use to warm the big building, trying to save. So we decided different system for winter, okay, winter during the day, winter during the night, how to protect all the different facades, the south and the north, and in summer, how to ventilate, how to eliminate hot from the inside, how to preserve the stream sun, and so on, in summer during the day and during the night. And we analyzed different materials, how to design the facade of the greenhouse with glass, with plexiglass or plastics, or with FT. Well, finally, we decide with ETFE, or ETFE depends on how you say, analyzing the different characteristics of the diverse materials. But finally, comparing the CO2 produced or emitted, the impact of CO2 of every material we use, trying to be the most sustainable as possible, not only during the use, but during the construction as well. Okay. Finally, here you have some images of the building that we are working on. Those are first ideas. We keep working on this now. Okay, I would like to finish with a video that we have produced, where you can see how it is supposed to it's going to be, more or less, from the former to the new one. This is the extreme facing the south with photovoltaic panels and these shapes that wrap the structure placed there, with a big auditorium and some room and offices. Then you enter inside, and we generate this path at different levels. You can walk in the ground level, in the first level, with this play with different stairs. The division in the parts is where the people cross and links one side with the other of the campus, entering the central part. The material we use is cross-laminated timber that is light and resistant, kind of like the structures. You can appreciate with different points of view, and the new structure we generate is simulating like living organisms as well, trying not to affect the existing structure. Crossing to the third part, different climates. Okay. You can have many experiences, spatial experiences, because the different paths, ways of going in the building. No? And going to the upper floor. These rooms. And finally, we go to the extreme in the north facade. You can cross, the building is a way to cross from one side to another side, okay? And without moving anything from the already existing structure, we generate different spaces for meetings, for work, for students, professors, whatever. And always having many points of view. And finally, in the upper floor, with a panoramic lift, there are several panoramic, we go to the restaurant, cafeteria and restaurant, very nice. It's a sightseeing place where you can have a beautiful view of the whole campus, and you can spend a very nice time. Okay. And in this campus, there is a lack of this kind of spaces. So we decided to introduce this area for meetings and having nice lunches, okay? So we tried to generate the maximum expressivity in design with the minimum of elements and the minimum of energy used, okay? Fine. So with these words about what is sustainable architecture, I say to you, muchas gracias, okay, or as well, mulțumesc. Pues, okay, thank you very much. I'm very nice to stay here with you. I left, I get out. Thank you.
Sorry, let's close here. So, Bogdan, vrei să-i spui ceva, Roze? So we are very grateful to you that you have shared. You have many. Now, it's hearable. Yeah, you can hear us. So you okay? So we are very glad that you presented to us a lot of inspiring ideas for our projects, and also from your experiences, especially all the concept of a biostructure in architecture and sorry. Okay, so trebuie să am sunetul ăla, eu nu. Și de aici, așa. So many thanks, dear Rosa, for the opportunity you offered to us to share with us your wonderful projects and all the experiences that you had, and especially the last projects that are very inspiring also for us, as we are working also now in the first year with the modules. So they are very interested, the students were very interested, and it was very nice. And because they are starting with the modules to share, for me it was very nice to see also the project of the bioreactors for algae, and also for the hangar in Alcalá. So all this evolution of the space, of the concept. And so I'm here, next to me is Professor Bogdan Fezi, is the coordinator of our atelier, and he had the wonderful idea to invite you, and I want to thank you, Bogdan, also. So.
Thank you to you both, very nice.
Allora, ciao e grazie mille. Ci vediamo di quella parte, non so dove ci vediamo, di questa parte. Allora, vi aspettiamo rapidamente a Bucarest. Prima di tutto perché sono tutti qui gli studenti che ha visto i studenti?
No, you didn't see our students.
No,
dobbiamo girare.
No, non ho visto studenti, non ho visto.
You can see us all.
Ah. Ciao a tutti. Very nice to see you. Sì.
So you saw us, yeah?
E anche noi siamo studenti giovanissimi, dunque tutto è a posto. No, ma dicevo che vi aspettiamo rapidamente a Bucarest, perché adesso tutto è calmo. Non sappiamo quanto tempo resterà così, ma siamo comunque ottimisti. Vi ringraziamo per questo passaggio in un'altra dimensione, la dimensione dell'architettura, dell'eternità, della natura e beautiful dreams.
Sì,
Grazie, grazie mille.
Grazie tante, piacere andare di là. Aspettiamo che sia meglio il tempo nel futuro. Noi finiamo con la pandemia, no? Aspettiamo.
Non si sente? Non si sente. È tanta tecnologia. Microfono di una parte, il suono di un'altra parte.
Așa, deci acum facem așa. Dăm de aici, dăm aici așa.
Sì, mi sa.
Stai că acum cum se face? Pe ce apăsa ca să nu
Si sente? No, ho capito, sì, ho capito tutto. Piacere per me. Io Mincu è molto carina, è un piacere stare con voi, so beautiful, very nice, and thank you very much for the invitation. And when the time is more reasonable, well, we can share in person with the students. Okay, of course. Tante grazie. Okay.
If there are some other questions from the students, if there.
Well, anyway, if you can share with them, and if they want something, you can write me, and we can whatever explain or share. Okay, fine.
Lots of thanks. Grazie.
Bye. Ciao.
Și mai sesizează.
Bine.